In progress.
In this video, I will show you how to calculate voltage and current across through each resistor. So we have a circuit diagram here. The question says calculate the current and the voltage across through each resistor. Therefore, we'll draw a table where we fill in the spaces. So now I want to calculate current and voltage through each resistor. I will show you on how to calculate and get all the marks. Now we have this kind of circuit diagram. The first thing we need to calculate is total current and total resistance. So we'll start calculating total resistance because we can't calculate total current without total resistance. When you calculate total resistance, you always start away from the source. What is our source? Our source is 12 volts, which is the V supply. We always start away from the source. We'll always start away from the source. So away from the source, we'll start with 20 and 10 ohms. How is 20 ohm and 10 ohm connected? They are connected in parallel. Why? It's because the both legs of 20 and 10, they are joined together. So they are connected in parallel. So to get RP1 is going to be equal to 20 times 10 divided by 20 plus 10. If you want to understand or know more about this, I've uploaded a video explaining on how to identify or determine whether resistors are connected in parallel or series. So the answer is 6.667 ohm. So RP1 is 6.667. So the law that we're applying here is circuit reduction. Circuit reduction, you reduce the combination of resistors by the answer you've got. So in some way, I don't know how can I put this, but let me try. Circuit reduction, you reduce, it's like we are reducing the loops of your circuit until you are left with one resistance and the supply. So now, since I'm applying circuit reduction, I will replace the combination of 20 and 10 with their value, which is 6.667. So always I will have to redraw. After calculating, you redraw the circuit and you replace the combination by the value you have got. There's still 12 ohm there, my V supply, my 5 ohm, that will be for 7 ohm, for 3 ohm. They will be replaced with 6.667, 20 and 10. Then 3 ohm still there, 7 ohm, 5 ohm, 12 ohm. This is still 25 voltage, 25 V, it won't change. So I've replaced 20 and 10. If you don't understand, go and watch the previous video I've just uploaded explaining on how to get the total resistance of a certain circuit diagram. So now, remember, I want total resistance. Now, is 3 and 6, how are they connected? They are connected parallel. They are connected parallel. Someone will say, no, but there's 5 ohm there. How is 5 ohm connected? 5 ohm is also connected series or parallel or something. 5 ohm, we can't include it here. 5 ohm or 7 ohm, we can't include them on our type of connection for 3 and 6. Why? It's because they are connected at the junction. They are connected at the junction. So we can't really determine the type of connection between 7 ohm, 5 ohm, 3 ohm, and 6 ohm, 0.667 ohm connection. But for 3 ohm and 6.667 ohm connection is a parallel connection. So what's that? So let's calculate that parallel connection value. It's going to be RP2 is equals to 3 times 6.667 divided by 3 plus 6.667 is equals to 3 times 6, 7 divided by 3 plus 6, 7 is equals to 2.069. So the combination of 3 and 6.667 is 2.6. So we'll redraw that circuit again. 7 ohm. So the combination is 2.09. So the 5 ohm will, the 7 ohm will still be there, and the 5 ohm, the 12 ohm. So what type of connection is 7 ohm and 2.069? The type of connection is series. Why? They are connected at one point. Then why can we include 5 ohm? It's because 5 ohm is still on a junction. A junction is where a combination of resistors meet. So 12 ohm and 5 ohm and 2.069, they meet at this point. So they make this point a junction. That's why we can determine a type of connection between 5 and 2. But for the one between 7 and 2, we can determine it, which is series. Then we'll calculate that series value, which is 7 plus 2,069 is equals to 9.069. And therefore, we'll replace that 7 and 2.069 by their total resistance, which is the 9.069, and the 12 ohm will remain there with the 5 ohm. So remember, it's a circuit reduction. That's why the loops, like the circuit, now it's becoming small. It was big, now it is becoming small. That's the definition of circuit reduction. We have to reduce the loops of our circuit. So how is 12 ohm, 5 ohm, 9 ohm connected on this circuit now? 12 and 9.069 ohm, they are connected in parallel. Why? It's because both legs of 12 and 9.069 ohm, they are connected together. So that's why I'm saying they're connected in parallel. But what about 5 ohm? 5 ohm, we can't really say it's connected parallel and series. We can't identify the type of connection of 5 ohm. But the one for 9 and 12, we can identify it, which is parallel. Therefore, we'll get RP3, which is 12 times 9.069 divided by 12 plus 9.069 is equals to 12 times 9.069 divided by 12 plus 9.069 is equals to 5.165 ohm. Then the final, the second, reduce it again. So where I'm going to put the resistor, the combination of 12 and 9, we can put it to the right or to the left. You can put it to the right or to the left, as long as this connection will still remain the same. If you put it to the left and right, you can put it anyhow, as long as you know what the connection will remain the same and will still be the series connection. So I got 5.165, then still here is 25V. So what is the total resistance? RT is equals to 5.165 plus 5 is equals to 10.165. Therefore, the final circuit is going to look like this. Remember, circuit reduction have to be left with one resistor and one supply. 10.165 there, my 25 V there. So now I have the final circuit. I can calculate my total current. Remember, total current is total voltage divided by total resistance. So now I will need to cancel this. Remember, the aim is to calculate current and the voltage of each circuit diagram. Aim is to calculate current and voltage of each circuit diagram. So I will clear this for more space. Since I recorded the values here, so I will clear for more space. So remember, the aim is to calculate the voltage and current across and through each resistor. Across and through each resistor. That's our aim. The question, they've asked us to calculate current and the voltage. So I will draw a table to simplify. A table. Draw a table to fill in current and the voltage for each and every resistor. The R stands for resistance value, I current value, V voltage value, and they also stand for SI units. So I won't write the SI units in the boxes. Let me just start with 12 ohm, 5 ohm, 7 ohm, 3 ohm, 10 ohm, 20 ohm. So I have to fill in the table. Therefore, remember, when we calculate the total resistance, we are going forward. Then when we want to calculate the voltage and the current, we will go back. So what we have done going forward, we will now do a reverse of what we have done. So we will go back. Now, let's start with total current. We can't get everything if you don't have total current. So total current is equals to, total current is IT. Total current is equals to, remember Ohm's law, 25, which is the voltage, divided by the total resistance. Therefore, 25 divided by 10.165 is equals to 2.459. So that's the total current. So that total current is the current in this loop. So it's the current that will flow in the last circuit. So let's go back. Remember, 10.165 is combination. 10.165 is combination of 5 plus 5.165. Since 10.165 is total resistance of 5 plus 5.165, that means the current through it is the same current that will flow through 5 and 5.165. Why? It's because 5.165 and 5, they are connected in series. So if we go back again, check, 5.165 is connected in series with 5. And what is the total current in that circuit? The total current in this loop, the total current in this circuit is 2.459, which is the total current. So since now 5 and 5.165, they share same current, that means will be 2.459 current, which is the total current. And therefore, we have 5 on our table, and the total the current through 5 is what? Is 2.459. So then we record the value we have got for 5 ohm on our table. Therefore, we check 5.165 we don't have on the table. Then we need to go back. We need to go back until we get the values of each and every resistor on our table. So what formed 5.165? 5.165 is formed by 12 and 9.069. What formed 5.165? 5.165 is formed by 12 and 9.069. How are they connected? 12 and 9.069. They are connected in parallel. What do we have? What do we have? We have their total current. We have their total current. We have their total resistance. Then what do we need? We need their total voltage. Why? It's because they are connected in parallel and they share same voltage. Therefore, let's get the voltage. V 5 point V 5.165. The voltage across 5.165 is equals to the current we have is 2.459 multiplied by 9 multiplied by by its total resistance. Remember, we want to get the total voltage of 5.165. So what is the total current of it? Is 2.495. Then what is the total resistance? It's 5.165. So 2.49495 times 5.165 is equals to 12.887. So the voltage across 5.165 is 12.887. Therefore, now remember, we're going back. What formed 5.165? 5.165 is formed by 9.069 and 12 ohm. How are they connected? They are connected in parallel. That means they share same voltage. What is that voltage? Is 12.887, since it's the voltage across 5.165 and 5.165 is the total resistance of 12 and 9.069. So we have 12 on our table. We are going to record its value. It's a voltage. Remember, it's a voltage 12.887. 12.887. Remember, we are going back. Therefore, the voltage across 12.12 and 9.069 is the same. So now, remember, we're going back. So now we are done with the left part. Let's check the right part. So the right part, 9.069, is formed by 7 and 2.069. How is the sum of the resistors of 9.069 connected? Series connection. So to get the current through 7 and 2, we need to get the current of the total resistance. The total voltage, we have it, which is 12.887. So the total current of 9.069 is equals to 12.887 divided by 9.069. Therefore, 12.887 divided by 9.069. 9.069. Then the total current is 4.20. 4.21. Sorry, I have to round it off 3 decimal places. 4.21 amperes. Therefore, the current that will flow through 7 and 2.069 is going to be the total current through their total resistance, which is 1.4, the total resistance, which is 9.06. Their total resistance is 9.06 and the total current is 1.42. So since 7 and 2.069, they are connected in series and their total resistance is 9.069. So they are current, the current that will flow through them is 1.42. Therefore, we have 7 ohm on our table. Then the current is going to be 1.421. So how do we go back? I'm not sure whether I'm making sense or what. So how do we go back? How do we calculate the current and voltage across each resistor? So that's how we calculate it. Remember, we are going back. What formed your resistance? What formed the resistance? And how and the type of connection is going to tell you what you need to calculate when you're going back. Since I'm going back, the type of connection is telling me what do I need to calculate. Like e.g., check. I'm moving, check. From the 10 point, the total resistance is 10.65. 10.65. I'm going back. What do I need to calculate? It tells me or calculate the total resistance. Why? It's because my resistance, they're connected in series. So if I get the total, I mean the total current is going to be series. Since I say series, I will have the current through them. So I'm going back, and now I have 5.16. I have 5.165. 5.165. I have the total current and the total resistance. So the type of connection is telling me or get the voltage. Why? Is because the combination of 5.165, they are connected in parallel. So to get the voltage across the both resistors, you need to get the voltage. So that's how I'm going back. The combination and the type of connection is telling me, or you need to get this to get both a voltage or current of your resistors. You see? So now we are going back. We are done with the 7 ohm. So now we have 2.069. 2.069 is a combination of 3 and 6.667. How are they connected? How are they connected? They are connected in parallel. So we need to get what? The voltage. We need to get the voltage because our resistors are connected in parallel. So we need to get the voltage of what? The voltage of their total resistance. It will give us the voltage of the resistors that caused or that formed the 2.069. So V 2.069 is equals to 2.069 multiplied by 1.421. 421. 4 is equals to 2.069 times 1.421 is equals to 2.94. 2.940. It's a voltage. So the voltage of 2.069 is the same voltage across 3 and 6.66. Why? It's because 3 and 6.667, they are the ones that formed the 2.069. So 2.069 is the total resistance of 3 and 6.667. So 3 voltage you have got it is 2.940. Therefore, let's check 6.667. 6.667. Remember, we are going back to the original circuit diagram. Therefore, that means we are done if we got the values of the original. If we are on the original circuit diagram, that means we are done. So now, now we're working on 6.667 ohm. 6.667 ohm is formed by 20 and 10. How are they connected? They are connected in parallel. So that tells us, or the type of connection tells us what you need to calculate. The type of connection tells us what you need to calculate. So we need to calculate what? Then we need to calculate the voltage. Why voltage? Is because the type of connection is parallel. And then to get their voltages, to summarize or get current and voltage through 20 and 10 is first get the voltage. Since they share same voltage, then we'll get the current after that. So since the 20 and 10 are connected in parallel, and we need to get the voltage. What is the voltage across 6.667? The voltage across 6.67 is 2.940. We already have the voltage, so we don't need to recalculate because we already have the voltage. So the voltage across 20, 10, and 3 will be the same because they are both connected in parallel. So that will be 2.940, 2.940. So the table is like this. We're almost done. So if you see now, it's like missing box. So we have the value of, then we just need this to get this. So we are almost done. So let's complete the table. I will start from the 20 ohm resistor. Get the current right by 20. The current through 20 ohm is 0.147. The current through 10 ohm is 0.294. The current through 3 ohm is 0.98. Then now voltage is 1.421 times 7. The voltage across 7 ohm is 9.947. The voltage across 5 ohm is 5 times 2.459, which is 12.295. 12 divided by 12. Therefore, the current through 12 ohm is 1.074. So we are done. Our table is complete. So we have answered the question. Question was calculate the current and the voltage of each resistor. Current and the voltage of each resistor. Then that's how we calculate. That's how we calculate current and the voltage of each resistor. That's how we calculate. First, start with the total resistance. You are going forward. Start with total resistance. From there, you'll go back by checking, and the type of connection, it will tell you what you need to get. It's either the current or the voltage. If you are going back and type of connection is parallel, you need to get the voltage. If you're going back and the type of connection is series, you need to get the current. And the total resistance that you are getting, the time you were going back, you were going forward, there will be the total resistance of your combinations. Remember, we applied a circuit reduction. So a circuit reduction, we reduced the circuit to a smaller circuit. So we have a bigger circuit, we reduce it to a smaller circuit. Therefore, now we will go back when you want to get the voltage and the current, we will go back to the bigger circuit. That means to get the current of each and every resistor. If you understand or you have a problem you don't understand, please comment. I will share my numbers. Comment. I will share my numbers. For more videos, subscribe and share with your friend. Thank you.